All right. So, like I mentioned, we did a little bit of this chapter or unit 3 on Tuesday. Um, if you weren't there on Tuesday because you were writing a midterm, you didn't miss much. We did a little bit of review from section or chapter 2 about potential energy diagrams. Now, the big thing for this class today is talking about reaction rate. Reaction rate is essentially how fast a reaction happens. I mentioned this on Tuesday. If you weren't here, not a big deal. But the idea is it's kind of like a speed limit. So, I mentioned on Tuesday, if you're driving on the expressway or, one of the highways in Qatar, the speed limit is usually 100 or 120 kilometers per hour. That's kind of like what a reaction rate is. It's measured in moles per liter per second. That sounds a little confusing, but it's the change in concentration per second. So when you guys do your next lab, you're going to look at this. Your next lab, I mean, I wish I was there. It's one of my favorite labs in all of the college. It's a measure of reaction rates. It's a little bit of a stinky lab. There's a sulfur reaction that's happening, so there's a smell that happens, but it's such a cool lab. You're going to look at how fast products form. So the idea with reaction rates is reactions with low activation energies, meaning low energies that make a reaction happen. If you weren't here on Tuesday, this means activation energy. That's the energy it takes to make a reaction happen. Reactions that have low activation energy are typically fast. Reactions that have a lot of collisions, a low activation energy, will typically be faster. So I have two examples on the bottom of this slide. I have an explosion on the left and rusting on the right. And I did mention this on Tuesday. An explosion is something that will happen within seconds, or I mean, less than a second. And something like the rusting of metal could take weeks, months, even years. So reactions don't always happen immediately. I mean, the easiest example I can give you is food spoiling. What I mean is, if you had an apple or an avocado or a banana that was turning brown, that's a chemical reaction. Chemically, biologically, your food is changing over time. And that could take, let's take an avocado or an apple. That could take a week, 5 days to change, to turn brown, to become inedible. So some reactions are very, very fast. Some reactions are very, very slow. It's just the nature of reactions. Now, my first wink of today. You definitely want to know this, wink, wink, wink. The rate of a reaction typically decreases over time. So what that means is, as chemical reactions are happening, reactants are being converted into products. As reactants are converting into products, that means there's less reactants. So that means because there's less reactants, there's less collisions. You can kind of think of this like traffic in Qatar. So think about the traffic on the roads at like 8 a.m. or 3 p.m. when school is finishing. There's so many cars on the road. I say 3 p.m. school is finishing, talking about like, K to 12 type schools. So there's a million cars on the roads, literally. There's everybody out there driving. and there tends to be a lot of collisions. However, at like say 1 a.m., after midnight, there's less cars on the road, meaning there would be less traffic collisions. So you can kind of think of reaction rates like traffic. When there's less cars on the road, there's less accidents, there's less reactions. So reaction rates decrease over time because there are less reactants. So two questions in the chat there. Iman, are you going to see an explosion? I doubt it. I think the only explosion you guys would have seen in chemistry labs are, if you can remember, and I know, Aman, you did this, and some of you students I had before did this with me in 1120. We looked at the reaction between pure sodium metal and water. That was definitely the most explosive reaction you would see in this course. And in chemistry. And Abdul Halim, no problem. I promise. The question was, or the comment was about my winking. I promise I'll give you guys more winks. A year ago, when classes were normal and I could be there in person, I did wink in person. So if you ever get to see me in person, I do actually wink. So this slide relates to your lab, and from what I heard from you guys is Miss Michelle postponed or changed your lab to happen next week. This is a good thing because now I can explain how do you calculate the rate of reaction. Well, if reaction rate is measured as mole per liter per second, and that's kind of a weird thing to think about, like moles per liter per second. But it's really quite simple. The average rate of reaction is the change in concentration over the change in time. Now, because chemical reactions happen so fast, we don't use hours. So the speed limit on the expressway is 100 kilometers per hour or 80. I haven't been on the expressway in years, but when I used to live in sports, I lived in Al Sad, so I lived next to Sports Roundabout. I would always take the expressway to come to work. And it was 100 kilometers per hour. Then they dropped it to 80 kilometers per hour, I remember, for safety. Instead of measuring chemical reactions per hour, we measure them per second because, again, many chemical reactions happen, in 1, 2, 3, 4, 5 seconds. Mole per liter is concentration. So the average rate of reaction is measured as its change in concentration over time. All right, there you go. Now, realistically, and okay, so this is kind of another wink, wink. This is not something I would worry about for a test, but you will see this in the lab. Excuse me. So why is that? Honestly, guys, to measure a change in concentration, it's quite difficult. There's no magical device or magical way to look at concentration changes. In physics, if you guys have done physics, you looked at velocity, the change in distance over time. That's easy, right? Physics, physics is easy. No, I shouldn't say that. Physics is quite hard, but measuring velocity is easy. You can measure the distance an object travels, right? You can use a ruler. You can measure the time it takes to go that distance, and you have velocity. Measuring change in concentration is much more difficult because you're trying to observe molecules. So in your lab next week, I cannot wait for you guys to do it, and I hope we get to talk about it next week. We have an ingenious way of measuring change in concentration, and it's by looking at how fast a precipitate forms. And you'll see this in your lab. I won't, I'm going to avoid spoilers. I don't want to say too much about your lab, not because I'm trying to confuse you. It's the easiest lab ever, but it's so interesting. And again, you're going to measure reaction rates next week by looking at a precipitate, a solid being formed in a solution. It's pretty, again, it's one of my favorite labs. I wish I was there. So here's an example. This will kind of get you ready for your lab here. This is a pretty good example because one way to measure concentration of particularly an acid, which this is an acid. We'll talk more about this in unit 4. But an acid, a good way to measure the concentration of an acid is pH. And I don't know if you guys have ever heard of that term. You will certainly hear about that term in unit 4, so I'll kind of leave it there for now, but we will come back to this in unit 4. pH is a unit of measurement for the strength of an acid. Okay, so let me clear my writing. How do we do this calculation? Very, very easy. Calculate the average rate of reaction of hydrochloric acid, that's HCl, for 15 seconds. So at 0 seconds before I even do the reaction, the concentration of HCl is 1 mole per liter. After 15 seconds, the concentration of the acid has reduced to 0.1 mole per liter. Again, guys, remember that this M here means mole per liter. This is concentration. So easy. Average rate of reaction is my change in concentration over my change in time. Now, one thing that's important here. Delta in physics and chemistry means change, and it's always final minus initial. And you should remember that from Q equals MC delta T, which you did on your test this week. So it's always my final minus initial. Why I'm bringing that up is if you do this calculation, you'll notice that you get a negative number. And that's fine. The negative number means the rate is, or the concentration is going down. So this is a good number. What I'm saying is don't get confused with the negative. So it's my final minus my initial. So 0.1 minus 1 and 15 minus 0. I divide them on my calculator, and my calculator says negative decimal 0.06 moles per liter per second. So what that means is, on average, my concentration is decreasing decimal 0.06 moles per liter every second. And that's good. Like, again, the negative is a good thing. So, excuse me, let me read the chat here. Okay, so 3 messages. So Harold, yes, if you ever have me in person, you should definitely look at my face. But I will mention that if you had me in a physical class, I do actually say the word wink, wink. So even if you don't see me wink, I still say the words wink, wink. And Iman has 2 questions. When the reaction rates decrease, collisions definitely decrease. You can think about it like if there's less molecules around, there will be less collisions. And then the other question is from Aman, does the question dissolve mean mix? Yes. Dissolve technically means mix into water. Sorry, that's not actually the definition, but that's the best way to think about dissolve. Sorry. Dissolve typically means to mix into water. Yes. So dissolve means mix. 99.9% of the times when you see dissolve, it means something is being mixed into water. And I only laugh because you can dissolve things in something other than water. But in real life, and in first year, second year chemistry courses, dissolve means mix into water. Anyways, I'm going to give you guys a minute to try this example. Oops, there's the answer. I don't want you to do that. So I'm going to give you a minute to try this guy. See if you can calculate the rate. Again, the rate is your change in concentration over your change in time. I'll give you literally a minute. This only takes, doesn't take much time, and I'll be back with the answer. Just to answer a question there from Aman, you had the word dissolved on the test. It means mixed. Dissolved and mixed, same thing. Same. I know what question you're asking about. It was the calorimetry question. Dissolved means mixed. And I'll give you a minute here and we'll look at the answer. So give this question a try. Excuse me. All right. So I have some answers in the chat here, and both are, I'm going to assume they're correct. Again, I don't care about significant figures or rounding, not really something I'm worried about. So the answers in the chat, I think I had what was it, 028, 029, they're both fine. Let's see. Hold on now, my computer's being mean to me as usual. Hold on, almost there. Okay. Perfect. So the average rate of reaction, it's final minus initial. Now, remember, this is my initial. This is my final. So I subtract my numbers. And in this case, I get a positive number. Now, this is an increasing rate of formation, meaning my concentration is going up over time. This is normal if I'm trying to create something. So you can think of this like in your very first lab. I don't know if you remember this, but you made an ester. You made something with a distinct smell. It might have smelled like pineapple or menthol or petrol, gasoline. When you're making something, typically the concentration, or sorry, the reaction is positive, and that's normal as well. So the answer here, technically, this would be, if I was being picky, I would call this decimal 0.29 moles per liter per second. Because again, that's just because of rounding. If this was a test, I don't care if you said 0.28. So for any of you students who said 0.28, doesn't matter. There's another question there about writing the units. Okay, that's a really good and important question. You really need to write the units correctly because little m per, and this is kind of like an English thing, I mean, I feel like your communications instructor almost, but it does matter in science. Little m per second means meters per second. Capital M per second means mole per liter per second. So, you know, I can't, this is a touchy subject for me because I don't want to take off marks for something so simple and ridiculous, and I never have. I don't think in my 8 years at the college in the Middle East, I've ever taken off marks for like a capital letter, an uppercase letter. But I don't want to be the instructor that says, oh, it doesn't matter, because it really does matter. In science, if you use a small m, you're talking about meters per second. If you use a capital M, you're talking about moles per liter, and they couldn't be more different. So to answer your question, don't worry about it on a test with me. But in the future, if you guys go on, maybe you'll do more chemistry courses. It definitely matters, and your professors will, I want to say hate you. They'll be very upset if you don't use capital M. It really does matter. All right, I love this slide. This is another, these two slides are, four slides, five slides, sorry, it's going on longer than I thought. But these next few slides, wink, 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 are good to know. And what I mean is you might get asked on a test, how could you make a reaction faster? And actually, this is something you'll see or you will be asked in your lab as well. So this is kind of where I'll end today, guys. I'm going to give you some ways to make reactions faster, and then halas, we're finished. And it's the weekend and I can finish marking your tests and you guys can take a break because you just wrote your midterms this week, and I'm sure you'd all love to relax this weekend. So just give me 5 minutes or less, but this is a wink, wink moment. I may ask you, how do you make a reaction faster? Before I do that, there's a question in the chat. It's a private message, so you guys can't see it, but it says, when the reaction is increasing, does it form a precipitate? The answer to that is that it can. Not every reaction forms a precipitate. Some reactions get hot. Some reactions get cold. Some reactions change color. Some form a precipitate. So the answer to that question, when the reaction is increasing or the rate is increasing, does it form a precipitate? Sometimes. But precipitates are only one example of a chemical reaction. Chemical reactions can be changes in pH, that's the acidity, changes in temperature, changes in color. So it's not always precipitates. Okay, so, no problem for that. So how do we make a reaction faster? Well, when you guys think about reactions, I want you to think about traffic. Think about cars on C Ring or the expressway, or a road in Qatar. A reaction happens when there is a collision, when there's an accident. Okay, so maybe don't think about accidents, but think about cars bumping into each other. A way to make a reaction happen is to increase the temperature. Now, in terms of cars on the highway, this means increasing their speed. And I know this firsthand. I mentioned maybe 20 minutes ago, when I lived in Al Sad, I used to take the expressway or D ring or whatever you want to call that road, between Esdan Mall and Landmark Mall. I'd take that road every day. And when I first came here, the speed limit was 100. And there was a time, and I don't know what it's now, but there was a time when they reduced the speed limit on that road to 80. Why? Why did they do that? Why did the government reduce the speed limit? Well, they wanted to reduce collisions. So they decreased the speed, meaning they decreased the energy, so there would be less collisions. Well, in a chemical reaction, you do the opposite. You increase the temperature. Remember what temperature means. Temperature is the speed of the particles. And by increasing the speed, there's more collisions, and they're more likely to have enough energy to break bonds. Okay, so that's number one. Again, I'm definitely wink, 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 going to ask you this. How do you make a reaction happen? The first thing is increase temperature. Temperature. The second thing, increase concentration. Concentration is equivalent to the number of cars on the road. Again, I mentioned this, 20 minutes ago. At 8 a.m. or 3 p.m., there are so many cars on the road because people are traveling to work, to school. There's a lot of accidents at 8 a.m. or 3 p.m. in Qatar. However, at 1 a.m. or 2 a.m. or 5 a.m., I used to work with a guy who'd come to work every day at 5 a.m. just to avoid traffic. He was a crazy person. There's less cars. So less cars, less collisions, less reactions. Sorry, I'm just reading the chat there. So yeah, if you increase concentration, which is moles per liter, that means there's more particles, there's more chances that they will combine. And like as Aman says, it's kind of like a billiards game, billiards or snooker or pool, whatever you call it. Back in Canada, we call it pool. I don't know why. But like billiards, yeah, you're trying to increase the contact between molecules, or for billiards, it would be the balls. And as Mana says, yeah, I think you definitely get a fine these days if you're speeding. I don't know the limit though. They did drop it to 80. I remember because it really messed. My few of my friends were so upset about it, but I don't know if they changed it back. But again, I'm talking about D Ring or the expressway. That road that kind of goes to Festival City, and I can't remember the speed limit. I haven't been on that road in so long. Anyways, okay. So and here's another way. I have 1, 2, 3 slides and we're done. And this is pretty quick. And then halas, we're finished. And I can go finishing marking your tests. Another way to make a reaction faster is if you're looking at a gas and you increase the pressure. Now, this is like increasing concentration. What I mean is when you increase the pressure on a gas, this is going back to 1120. I don't want you to think too much about this today. I really think you guys need to take the weekend and relax because you just had midterms. But when you increase the pressure, what you're doing is decreasing the volume. So at high pressure, you have less volume. What that means is the particles are closer together, which means they have a higher concentration and there's more collisions. There's a lot to unpack on this slide. There's a lot of terms I'm throwing at you. So increased pressure means there's less volume. Less volume means you have an increased concentration. There's more moles per liter, and that means there's more collisions. Okay, this one's a little bit easier to think about because if any of you drink coffee or tea, you've probably experienced that or experienced this, sorry. You can, and you don't see this too often, but you can buy sugar for your tea in cubes. Okay, and you can also obviously get sugar for your tea or coffee in a powder. And to dissolve it quicker, it's much easier to use a powder than a solid. And the reason is because there's more surface area. So this would dissolve faster than this. Okay, and again, when you grind something up, I mean, if you guys are into cooking, typically when you're mixing ingredients, the recipe says to grind them or to whisk them. Ingredients that are in powder form or chemicals that are in powder form, instead of this giant solid, they're more likely to react faster because there's more room, or what we would call surface area, for collisions. And finally, the last one. And I don't know if we've talked about this yet. This is kind of something I think I'll get into on Sunday when we have class. But the last way to, and I'll mention this more on Sunday, so make sure you come to class next week. Because this guys, I could talk about for 10 minutes and we don't have 10 minutes. You can make a reaction faster by adding a catalyst. Now, anybody who's into cars, you might have heard of the term catalytic converter. There's a catalyst in a car that helps convert exhaust or chemicals from your car into less dangerous chemicals, better for the atmosphere. What is that? What is a catalyst? Whoops, I didn't mean to click. A catalyst is a chemical that helps a reaction happen faster. And the way that a catalyst works is it lowers the energy you need to make a reaction happen. It's like a chemical shortcut. Now, if you don't know what I mean by the word shortcut, I mean like, just imagine you're driving from Algarafa to West Bay, and somebody might take you. So again, Algarafa, if you're familiar with the area, like behind like near Education City, and you're driving to West Bay. Somebody might take you up towards Festival City, then you might come down towards the college and work your way to West Bay. That would be a normal reaction. A catalyst gives you a shortcut. So a catalyst is like cutting through the center of Doha. Maybe I think it's Al Markia Street. You cut down there instead of taking the long way. And again, we'll talk about this on Sunday. But it's creating what's called, it's creating a shortcut. It's giving the chemical reaction a quicker way to turn into the products. So again, it's like, taking a shorter route to drive somewhere. I don't know. Maybe on Sunday I'll give you a better example, but it's been a long week. I'm sure you guys have had a long week. Oh, and Aaron, wow. Yes. Enzymes, that's amazing, actually. So a few things, and then I'm done. Hadil messaged me privately. You will get your marks by tonight. I'll put them up in PeopleSoft tonight, so you'll have your test marks today. Abdul Halim, a catalyst is a helping agent. It lowers the activation energy and makes reactions faster. Beautiful definition. And then Aaron, wow, I'm so happy you brought that up. Enzymes are catalysts. So enzymes in your body help break chemicals down faster. They help you with metabolism, for example. Yeah, so any of you biology students here, enzymes in your bodies are catalysts. That's amazing. All right, I'm very happy with today. I'm going to stop talking now. I hope you guys relax this weekend. Don't worry about your midterms anymore. And if you have any questions, let me know. But other than that, I am finished for today. So have a great weekend. Stay safe. Wash your hands. Wear a mask.